The center manifold theorem states that the center manifold, in contrast to the stable and the unstable manifold, may be non-unique. That's somewhat strange because it's defined to be tangent to the center eigenspace, and so why would there be more than one manifold that are satisfying the condition to be tangent to that space? Well, let's see that in an explicit example where we can calculate it. And so let's just take a very simple example where the x-axis is the center eigenspace, the y-axis is the stable eigenspace, and so we have a center manifold which would be given by y equals h of x, and h of x is determined by the condition that on the one hand y dot is given by this equation, on the other hand y dot is also given via x dot through the center manifold. And so we have the equation that dh by dx times x dot, which is minus x cubed, has to be equal to y dot, which is minus h plus x squared. So this is linear in h, and therefore we can actually solve it exactly. So we get dh by dx minus 1 over x cubed h equals minus 1 over x. And using an integrating factor, we get then d by dx times e to the 1 over 2x squared times h equals e to the minus 1 over 2x squared times 1 over x. Let's see whether that's right. Not this minus sign. And when we now integrate, we get h is given by minus the integral of e to the 1 over 2x prime squared over x prime dx prime times e to the minus 1 over 2x squared. That's from here. And then we need the integration constant, so we have an arbitrary constant c times e to the minus 1 over 2x squared. So that's the general solution for that center manifold. One can write this thing here in terms of the exponential integral, which is just another special function. So it's not much is gained by writing this down here. But the important point is that to see that all these different functions h are all tangential to the center eigenspace. And so if you expand now, to see tangency, we need to see that the derivative of the center manifold is actually 0 at the origin. And so if you expand this in x, you get x squared plus, let me just copy it, plus 2x4 plus 8x to the 6 plus order x to the 8th, and so on. This comes all from this term. And then we still have this guy here, c e to the minus 1 over 2x squared. And the important thing here is simply that this function has a Taylor expansion which is identically 0. It's non-analytic at the origin. It's not analytic at x equals 0. And arbitrary derivatives of e to the minus 1 over 2x squared at x equals 0 are equal to 0. So it doesn't matter what this integration constant here is. This center manifold is always tangential to the center eigenspace. This constant here, the purpose of the function of that constant is that you can satisfy arbitrary initial conditions. So let me sort of just sketch this. I don't have the function handy here, but so what it means is that we have so if these are our axes, x and y, and so this expansion here looks sort of like this. And but the precise graph is actually in notes, but so you have a function like this, and for different values of c, this is maybe c equals minus 1, and if you take a different value for c, it looks indistinguishable from this curve here, and then it goes someplace else, this maybe c equals 4 or something like that. But in this regime for small x, the difference is extremely small. And it's extremely small, reflecting the fact that the Taylor expansion of this difference between them is identically 0 at the origin. And so that's why the center manifold is not unique. And as I said, the coefficient c allows you to satisfy arbitrary initial conditions. After all, these are all trajectories for some initial condition. Say if you had this initial condition, well, then the green or trajectory would be the solution to the differential equation. If this had been the initial condition, it would be the blue line. And after a short transient, all these trajectories are indistinguishable, literally indistinguishable in terms of their Taylor expansion. The Taylor expansion is identical here, and it's just this difference, that this term that differs between the two different trajectories.